Welcome to lesson number 2. Today we're going to be looking at analyzing quadratic functions. So just a reminder, quadratic function is one that can be written in this form: f of x is equal to ax squared plus bx plus c. And in equation form, it would be y is equal to ax squared plus bx plus c. If we have a quadratic equation, it is an equation which can be written in the form ax squared plus bx plus c is equal to 0. And what we found in the previous lesson is the roots of the quadratic equation are equal to 0, and the zeros of the related quadratic function are equal to that quadratic equation, or f of x is equal to ax squared plus bx plus c. Now, there's two ways that we can write our quadratic function. It can be written in general or standard form. So in general form, that's kind of what you've been used to, is as a function, f of x is equal to ax squared plus bx plus c, or as an equation, y is equal to ax squared plus bx plus c. And in standard form, we would have it as a function where a is factored out, and we have x minus p squared plus q. And we'll talk about how we would derive these in a later lesson. And y is equal to a times x minus p squared plus q. So let's move on to our first investigation. And in this first investigation, what we're going to be doing is we're going to be analyzing the graph of specifically y is equal to x squared. And for this part, what we're going to need is our calculators. And actually, for this first part, we don't really need our calculators, so I'll just back that up. But anyways, we want to graph the function that has the equation y equals x squared by completing the table of values. We want to join the points with a smooth curve. The graph of this function is known as, or it's called a parabola. So let's see what our parabola looks like. When I have my value of x is equal to -3, I would have -3 squared, which is equal to 9. So again, to get this value, I just plug it into my equation, and that is -3 squared is 9. So when it's -2 squared, if I replace x with -2, is 4. -1 is going to be 1, 0 will remain 0, 1, 4, and 9. So these are the values of my y and my values of my x. Now when I place these on my graph, we start left to right. First of all, I have -3 and positive 9. So 1, 2, 3, and 9 is right here. I have 2 and 4. 1, 2, and 4 is here. I have 1 and 1. -1 and 1, sorry. 0 and 0. 1 and 1. 2 and 4. And 3 and 9. 3 and 9. X equals 3. Y equals 9. Now we want to connect this with a line, and this gives us the shape of what is known as a parabola. We could continue these values in either my negative x or in my positive x directions, and if we do that, this becomes an infinite line which will continue upwards. Now let's look at some of the characteristics, or as it is saying, let's analyze this graph. So the axis of symmetry, this is the mirror line that splits our parabola in half. So our axis of symmetry, if we were to take this parabola, which is the name of the curve, and split it in half, we would have an equation right here at x equals 0. So our axis of symmetry would say is x equals 0, right here. The vertex of a parabola is where the axis of symmetry intersects the parabola. This can also represent a minimum point or a maximum point, depending on whether the parabola opens up or down. This parabola opens up, which means it points up, which means we have a minimum point. So our vertex is a minimum point, which is at 0 and 0. So the vertex is given as the coordinates 0 and 0, right here. The maximum or minimum value of a quadratic function occurs at the vertex and is represented by the y-coordinate of the vertex. And we want to now complete the following. So the blank value of the function with equation y equals x squared is, so again, we had a minimum value. It's a minimum value because every value, and I spelled minimum wrong, whoops, apologies. So the reason it's called a minimum value is because this is the lowest value on this parabola that is opening upwards. So if we were to take a look at all these values, so for example, this one is at -3 and 9, we're looking for the lowest y value. So the lowest y value is 0, and that's right here. So we would say that the minimum value of the function is 0. Now let's say the domain and range of the function with equation y equals x squared. Again, that's this function here. Now, the domain, this pertains to all the x values. So these are all my x values. Now, any x value is possible. So if I were to say, hey, can you find me -1 on this graph? -1 is right here. Now, if I were to ask you to look on the line and find me -1.5, so here's -2, here's -1, -1.5 would be right here. And that would pertain to a value on my graph because I would find it on the line. Now, any value on the x-axis is going to pop up on my graph. And so what that means is we would just say that x is an element of real numbers. So any real number that we have will be a value on our graph. The range, however, is a little bit different. My range, notice how we have all these values of y's. So if we were to extend this upwards, then we're going to continue to find values of y that work on our graph. However, anything below 0 is not on our graph because our graph doesn't exist anywhere below my x-axis at 0. So what this means is our range, and this pertains to the y values. My range would be that y has to be greater than and inclusive or including or equal to 0. And all the values, since we're given this, are elements of real numbers as well. Now, let's analyze the function with an equation y is equal to a x minus p squared plus q, where a is equal to 1. Now, in this lesson, we're going to be looking at 3 different investigations. So what we're first going to be introduced to in this investigation is what is known as a transformation. So a transformation is just the relationship that any of these equations that we're looking at have to x squared, y equals x squared. And this is the function we just looked at. So a transformation, what this means is we can move a figure from an original position on our graph to a new position. So in each investigation, we're going to be using our graphing calculators to sketch the equation. So first of all, what we want to look at is the graph of y equals f of x is equal to x squared. We want to graph this. So anything that you have, and actually let me clear this. In order to get to my graph, I want to press the y equals under stat plot right there. And all I'm going to do, this is my y equals, I'm going to type in x, so this button here under link, and then x squared. So that's my function. It's going to look something like this. Now, if your window settings look like mine, then what you can do is just go to zoom, and we want our standard graph, which is going to look like this. So I went to zoom, and I pressed option 6, and it gives me something like this. So first of all, what we want to do is graph x squared, and we get something like that. Oh, you can adjust your window settings so they're equal to this, or we can just, and actually, yeah, that might be easy. So if you want to adjust our window settings so they look like this, then my minimum x value is -5, my maximum x value is 5, and my x scale, it means it goes up by 1 each time. And then it's the same for my, well, actually, sorry, no, it is not. It goes from a y minimum of around -6 and a y maximum of about +10. It looks something like this. So we want to write an equation which represents each of the following. Y is equal to f of x plus 3. So if f of x is equal to x squared, then what we're doing is filling this, or substituting f of x with x squared. So y would equal x squared plus 3. And if I am doing the same thing with -3, I'm saying y is equal to x squared minus 3. Now what we want to do is graph this on our calculator. So on our calculator, let's see what happens when we have x squared plus 3. And notice how it took the same graph and it moved it up 1, 2, 3 spots. And when I have x squared minus 3, that should move it down. Let's see. 1, 2, 3. So the same graph of x squared, but it's moved up 3 units and it's moved down 3 units. So what we want to do now is we want to sketch each of those on our grid. So this point here would move up to 3 positions. These points at 1 would also move up 3 positions. And everything would move up 3 positions. So at 2 and 4, we would now be at 2 and 7. 5, 6, 7. So our graph is going to look something like this. And down here, everything moved down 3 positions. So at 4, it's going to be at 1. And at 9, 5, 6, 7, 8, 9, 2, 3, down. All right. Now, what we want to do is talk about what happened. So, looking at this graph, when I have y equals x squared, a vertex at 0 and 0, you know, all these characteristics of y equals x squared that we found earlier, we now want to talk about where these new positions are going to be. So, the new equation looks like this. Y is equal to x squared plus 3. My vertex moved upwards. So this was my old vertex, and for my second transformation, it moved up to 0 and 3. So plus 3, up 3. And now I have a new minimum value. My minimum y value is 3. And the axis of symmetry remains the same, so if we were to cut this in half, it's still going to be at x equals 0. Now what this was, the translation moved vertically. So we would call this a vertical translation, and it moved up, so 3 units upwards. So vertical translation, 3 units up. Now we had the reverse happening in this equation here, where it was x squared minus 3. We will now have a minimum value of negative 3 and a vertex of 0 and negative 3. So again, a minimum value of negative 3. And when I have my axis of symmetry, this will remain the same. However, in terms of the translation or the movement, this is a vertical translation is what we call it. And that's 3 units down. Now what this means is anytime I make a change of q units of x squared plus q, this means that our vertex will become the value of q if our function is x squared. And so that makes a minimum value of q. The axis of symmetry is unaffected, but it results in a vertical translation. And in this case, it'll be q units, and because it's plus q, it would be q units up. So what is the effect of the parameter q on the graph of y equals x squared plus q? So if we have a parameter q, all this does is this translates the graph of x squared up q units, q number of units. Compared to the graph of y equals x squared, the graph of y equals x squared plus q results in a vertical translation or a shift of q units. So if q is greater than 0, so plus q, the parabola moves up. But if q is less than 0 or negative, the parabola moves down. Now let's look at investigation number 2. The graph of y equals f of x is equal to x squared. And again, we're showing what that looks like. And we want to, and we want to, again, have the same equations on our, but this time we want to get rid of the two that we added initially. Now, we want to write an equation which represents each of the following: f of x plus 3. So now, if I have f of x is equal to x squared, what we're doing is we're making a substitution of x plus 3. So this is going to be f of x plus 3. What that means is anytime I have an x in my function, I need to replace that with x plus 3. So now our function goes from x squared to x plus 3 squared. Notice how my x plus 3 is in brackets. If I follow that same line of reasoning, I'm replacing the value of x with x minus 3. So this function is going to look like this: y is equal to x minus 3 squared. And we are going to want to graph both of these as well. So when I graph these, it's going to look like this: x plus 3 squared. And look at what happened. This moved this was x plus 3. This moved my graph 3 units, 1, 2, 3, to the left. So when I have x minus 3, what we should see happening is having our vertex over here. So let's do that. X minus 3 squared. Boom. There it is. Now, let's see what's going to go on here. So my first graph, or my first function, I'm going to graph over here. And now this moved over 1, 2, 3 positions, and it's going to look something like this. So notice how it was just a horizontal translation. And we had the opposite going on with my other graph. So 1, 2, 3, another horizontal translation, but this time in the opposite direction. So we want to now complete this chart. This was my original graph. However, when I have f of x plus 3, my new equation became y is equal to x plus 3 squared. This resulted in a vertex of -3 and 0. And still a minimum value of 0. However, my axis of symmetry changed. Now, if to cut this in half, we would have to go to x is equal to -3. This results in a horizontal translation of 3 units to the left. With this equation, we had y is equal to x minus 3 squared, where this is going to be +3 and 0. That's still a minimum value of 0. However, our axis of symmetry moved to x is equal to +3, and this results in a horizontal translation, 3 units to the right. So you're probably seeing the trend here. So whatever the translation is going to be, it's kind of reverse of what the equation says in terms of the sign. So if I put p units here, this will change my vertex by p units. However, it does not change the minimum value, but it does change the equation. So if it's -p, this would be x equals +p. And this is a horizontal translation. P units. If it's negative here, that means it's going to the right. So what is the effect of parameter p on the graph? So parameter p, this results in a horizontal translation of p units to the right. So if we compare to our graph x squared, the graph of x minus p squared results in, again, really trying to hammer this home, horizontal translations or a shift of p units. So if p is greater than 0, then the parabola moves. So if p is greater than 0, what this means is that this is going to go to the right. If p is less than 0, this will mean the parabola will move to the left. Now, with class example number 3, or sorry, investigation number 3, we're just combining all of this. So as we combine this, we want to write an equation which represents f of x plus 2 minus 4. So f of x minus 2 plus 4, or sorry, minus x plus 2 minus 4. So if my original equation is f of x, then remember, then this we're substituting for my x. So this is going to be y is equal to x plus 2 squared, and then minus 4. And we want to predict the transformations on x squared and a, and we want to use a graphing calculator to verify the results. So if this is my original graph, I know it's going to start at the origin, but first of all, it's going to be moving down 4 units, and it's going to be moving to the left by 2 units. So a horizontal translation, 2 units left, and a vertical translation of 4 units down. And let's confirm with our graph. So let's get rid of those. My new graph is x plus 2 squared, and then we're subtracting 4. So it'll pop up my first graph, here it is, and my second one should be over here and over here. So 2 units to the left, boom, and 1, 2, 3 units down. Or sorry, 4 units down. 1, 2, 3, 4, boom, right there. So if we write our new equation, this would be y is equal to x minus p squared plus, or sorry, x plus 2 squared minus 4. Let's start doing that one. And my vertex is going to be, well, we went down 2, or sorry, went to the left 2, so that would be negative 2, and then we moved down 4 and negative 4. And now we have a minimum value, and that coordinate is going to be at negative 2 and negative 4. Or sorry, I just replaced that. This should just say minimum of negative 4. This is why I should use pencils. So this is a minimum of negative 4. My axis of symmetry is x is equal to negative 2. And we had a translation, 2 units left, 4 units down. Now, if we have our f of x equal to x minus p plus q, then my new function is going to be x minus p squared plus q, giving me a vertex of p and q, a minimum value of q, a axis of symmetry equal to p, and a translation of p units right, q units up. Now, with each of these, we want to determine what the translations are going to be. So first of all, with this one, this is a horizontal translation, and this would be 10 units left. Because this is positive, this is actually going in this direction. When I have positive 4 outside of brackets, this is a vertical translation, 4 units up. And then over here, we have to adjust this graph so it is in the form of y equals. So this would be y is equal to x minus 5 squared, and I have to subtract 8 over here. So this would be a horizontal translation of 5 units right, with a vertical translation of 8 units down.